So, welcome, dear participant, in today's online session on SPSS, and uh, the session is planned for two group comparison. So, today is the 16th training day, and the level of training is intermediate now, and the date is 29th March 2024. Time is 9 p.m. to 9:40 p.m. Myself, Zahid Rashid. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. So, what we have covered till the last part of our training, we have covered up till the mean comparison based on single group mean comparison. And we have covered half part of two group mean comparison yesterday, and the remaining part of two group mean comparison will be covered today. And more than two group mean comparison will be covered on Monday. This is the part that we are going to cover on Monday that will complete the mean comparison. These are some of the topics that we will cover in the next week, because today is the weekend day. Uh, Today is Friday, and Saturday and Sunday sessions will be off due to usual session break at the weekend. So we will cover the other topics in the upcoming days from the Monday. So let's start today's discussion. These are today's topic. We will discuss the equality of variance when violated for normal data and not normal data. So what to do when equality of variance is violated with normal data? Yesterday we have considered normal data with assumption of fulfilling the equality of variance assumption. So yesterday we have normal data, and we have also verified equality of variance. Today we will discuss a case where data is normal, but equality of variance is violated, and another case on not normal data. So let me start the part. That is the case number two, normal data with unequal variance, where the normal data also indicates the variance is not equal. So whenever the data fulfills the normality assumption for a continuous variable, which is comparable in two independent groups, the test appropriate for such data would be independent sample t-test. However, equality of variance is violated under that, because we are going to use independent sample t-test due to normality. But equality of variance may be violated under this test. So what are the further consideration? We are going to check, for example, number 4. If you have, I have shared with you the data set. Uh, I have shared with the participant this data set. Yesterday we have discussed the first one, normal with equal variance. If you open the data set that I have shared with both of the participants, so this would include normal with equal variance, normal with unequal variance, and not normal. So today we are going to discuss normal with unequal variance and not normal. So you need to extract both of these data sets. The first one we have used in yesterday's section. So today we are going to use the other two folders, normal with unequal variance and not normal. So if we open the normal with unequal variance, we have two data set here. The first one is related to example number 4, and the fifth one is related to example number 5. So we are going to open example number 4 data set, and meanwhile we need to read this data set. We need to understand the specific detail of this data set. In our sample data set, students reported their typical score of math and English. and their gender, male and female. Suppose we want to know if the average score of math and English is different for male and female. So we have two groups. One group is related with the male student, and one group is related with the female student. And we are interested to know whether there is a significant difference of the average score of math between male and female, and the average score of English between male and female. So here we are two groups, and we are having two different subjects. So what is the hypothesis here? We need to understand the null hypothesis is there is no statistically significant difference in math and English score between males and females. So we assume under null hypothesis that both are equal. It means males and females having equal scores in math and English. While our alternative hypothesis would be there is statistically significant difference in math and English score between male and female. So this is the consideration that we need to test here using our data set. So this is the statistical formation of your hypothesis. Under this formation, H naught, which is null hypothesis, indicates that the average mean of your data is equal to the average mean of your second group data. So there are basically two groups here, group 1 and group 2. One group is related with males and one group is related with females. So we assume here that there is statistically significant difference of math and English score between male and female. So we assume here that the math and English score of male is equal to female in case of null hypothesis, because null hypothesis state that there is no statistically significant difference. While in case of alternative hypothesis, we assume that there is a statistical significance difference. It means they are not equal. They are having different results for math and English based on male and female data. So we need to go further. So what are the required steps in SPSS? First, we need to check the normality of the data. If the data is normal, then use independent sample t-test and check the equal variance assumption using Levin test that I have explained yesterday in my previous section. So this is the procedure that we adopt for testing the normality of our mean comparison method. We go to analyze, we go to non-parametric test, we go to legacy dialog box, and we go to one sample KS. And then we put the math and English, because in this data set, there are a lot of other subjects too. So we are interested in only math and English subjects, that we are comparing this subject in terms of gender. So we need to put both subjects in this box, in the test variable box, and we need to click OK. And then we will find out that asymptotic value in case of English and in case of math, both is greater than 5%. So it means our data is normal. Our distribution of the data for English and for math is normal here. So what we need to do, we need to interpret the normality test and decision about appropriate test. Normality test is, since the level of significance asymptotic sig2 tail is equal to 0.200 for both subjects, math and English, which is greater than 0.05, therefore the normality assumption is fulfilled. As the normality assumption is fulfilled, so what is our decision? As the data is normal, therefore independent sample t-test will be used for testing the hypothesis. However, we additionally need to check for equality of variance using Levin test of equal variance. So first of all, we need to consider the procedure of normality here. If you see here, we have a data like this. As I have told you that you need to go for example number 4 data that you can find in this file, normal with unequal variance. So you need to open example 4 data, and here it is open. As we are comparing the math and English score between male and female, so these three variables, there was an interruption in the internet, but I have connected again with the strongest one. So I was discussing that according to this example, we are comparing the score of math and score of English between male and female. So there is a gender variable here, there is a English variable here, there is a math variable here. So what we need to do, we basically go to the analyze section. We go to analyze, we go to non-parametric test, we go to legacy dialog box, we go to one sample KS. So what we need to do, because the math and English, they are basically the continuous variable here, math and English. So we need to put them here like this, and you will find their value, their asymptotic sig value is greater than 5%. So we have already discussed that as the significance level of asymptotic sig2 tail is equal to 0.200 for both subjects, math and English, which is greater than 0.05. Therefore, the normality assumption is fulfilled. So what we have decided till this level, we have decided that we are going to use the t-test for our further procedure, and we will also check for equality of variance. So what we do now, we go to analyze, we go to compare means, we go to independent sample t-test. So we need to click on it, and always remember that you need to put your continuous variable in the test variable box, like English and mathematics. And you need to put your categorical variable like gender here into grouping variable. Now you need to verify the grouping of your categorical variable too. So you need to go to here and you need to see the categorization of your categorical variables. So they are categorized with 0 and 1. So you need to put 0 and 1 into your define groups procedure. So you need to put here 0 and 1. Always remember the coding should be same here. If 0 and 1 is placed there, you need to put here 0 and 1. If 1 and 2 is placed there in your categorical variable, then you need to place 1 and 2 here. So always remember that coding should be same. If coding is different, you will either face an error in the procedure, or you will face or you will see some wrong estimations here. So you need to verify this coding scheme. So click on continue, click on OK, and you will see the results like this. Now, before interpreting these results, I would like to show you this procedure in the bigger screen here. I have applied this procedure. I go to analyze, compare means, goes to independent sample t-test. Then I have reported these results. First of all, you need to see the group statistic. If you see in case of English, the male and female results are similar. They are giving the similar results, and there is a very little difference between them. If you see here, there are 188 female and 213 male in this data set. So female on average are getting 82.72 or 73 marks in English. while male are getting 82.75 marks on average. So if we consider this decimal difference, the male are getting more marks. But if we are considering the full digit, they are same. If we see the mathematical scores, the females are 198 and they are getting 66.55 score on average in the mathematics. While the males, which are 215 in number, they are getting 64.33 on average marks. So here we can see that there is a very little difference. There is a difference of approximately 2 digits here between male and female. Let us check whether this difference is significant or not, or whether this difference is really meant here. So first we need to see the independent sample t-test. Here, if you see the t-values and sig value, they both are insignificant. If you see the t-value is less than 1.96. So it means these differences are not significant. If you see the first part, this is related to English. So English score difference is not significant. It means H naught is not rejected here. It means there is no significance difference between male and female average score in English subject. The second thing that you need to verify here is the Levin's test for equality of variance. This value should be greater than 5%. But if you see this value is less than 5%. It means equality of variance is not ensured here. So in that case, we reject the first assumption, equality of variance. Now we are considering equality of variance not assumed. So we need to ignore the first row and we need to see the second row now. Always remember, if this sig value is greater than 5%, it means the equality of variance assumed assumption is fulfilled. But in our case, as this is less than 5%, it means equality of variance assumption is rejected here. So we are going to accept the second row results. So we will see this row now. Now, if we see the t-value, here the t-value is also less than 1.96 and sig value is also greater than 5%. So we can conclude here that there is no significance difference. There is no significance difference between male and female in English subject. Now, if you see the mathematics here, you would also verify the t-value. Their t-value is greater than 1.96, but if you see the Levin's test for equality of variance, this value is less than 5%. So here we conclude that again, equality of variance assumption is not fulfilled. Sometimes it happens that in one subject, it may be possible that equality of variance assumption is fulfilled and in the other one, equality of assumption is not fulfilled. But in this case, in both of these subjects, English and mathematics, the equality of variance assumption is not fulfilled. So what we need to do again in mathematics, we need to consider the second row, which is equality of variance not assumed here. So we need to interpret these values of second row. Let's suppose if your assumption is fulfilled for equality of variance, it means t is greater than 5%. In that case, we need to interpret the first row value. So as this assumption is not fulfilled, so we need to interpret the second row, like same as we have done in the English subject. We need to interpret the second row. So here, if you can see, the t value is greater than 1.96 and the sig value is less than 5%. So we can infer here that there is a significance difference between male and female for mathematics subject. So what we have concluded here, there is no significance difference between male and female for English subject, but there is a significance difference between male and female for mathematics subject according to this t value. And this is the mean difference, and this is the confidence interval values. Now, if you see the effect size is very small. This is very small. This is close to zero value. So we can consider the effect size is not good here in case of English subject. But in case of math subject, it is a good value, 0.268. It is approximately 27% impact, which is considered uh, uh, a medium size impact. I will let you know the criteria of deciding these, but always remember if the value is close to zero, it means there is no impact. While if the value is greater than 20% and less than 35%, it is considered medium impact. So in case of mathematics subject, there is a medium impact, but in case of English subject, there is no impact, and we can verify there is no significance difference here. So, what is the correct interpretation here according to APA style? English score and male and female. So the result indicate that there is an insignificant difference. There is no significance difference between male and female for English score. So you need to place the p-value here. It is less than 1.96 and p-value is greater than 5%. So we can conclude here that there is no significance difference between male and female for English score. And the finding also indicate that males score more on average for English subject as compared to female, but this difference is not significant here. Let me show you mathematics score for males and females. The result indicate that there is a significance difference because I need to put here the p-value. Maybe I forgot. Let me check the t-value. The p-value for mathematics score is 2.756. So I need to place here 2.756. 2.756. And the p-value is, if we see here, the p-value for mathematics score is 0.006. So we need to put it here, 0.006. 0.006. Yes. Now it is corrected now. So what we have concluded here, in case of mathematics score, there is a significance difference. The t-value is minus 2.756. The p-value is 0.006 in the mean score of mathematics between male and female. The finding also indicate that females score more on average for mathematics subject as compared to male. So you can place their individual mean score here. So this is how you can interpret in terms of APA style for your consideration. So there is another example, example number 5 for your drill. You are provided with the height data for male and female. And can you conclude that there is a significance difference in the height for male and female data? So you need to apply the same procedure that I have completed right now. For example, number 5. While the data available, for example, number 5 is in the same folder, you just need to open this data and you need to apply the same procedure because it will also consider the normality with unequal variance assumption. So the next thing that we need to consider is this is your homework actually. Example number 5 is your homework. So you need to consider this for your further consideration. Now we are going to consider the not normal data for two group comparison. So if we have two groups, and our data is not normal, what we need to do. So this is the case we need to consider for today. When your data does not fulfill the normality assumption for a continuous variable, which is comparable in two independent groups, the test appropriate for such data would be Mann-Whitney U test. So if your data is normal, you are going to use independent sample t-test. But if your data is not normal for two group mean comparison, in that case, you need to use Mann-Whitney U test. In that case, you don't need to check the equality of variance assumption. This assumption is only, you need to check this assumption only in case of independent sample t-test. In case of Mann-Whitney U test, you don't need to check this assumption. So there is only one consideration, which is normality. So you need to fulfill the normality assumption here. So what are the detail of this test? Mann-Whitney U test. The Mann-Whitney U test, also known as Wilcoxon rank sum test, is a non-parametric statistical test used to assess whether there is a difference between two independent groups in terms of their distribution. It is commonly employed when the assumption of parametric tests such as t-test are not met. It means your normality assumption is not fulfilled here or violated here, especially when dealing with the ordinal or not normally distributed data. So here median is compared as an average instead of mean. So this is basically the feature for applying this test. You are going to use median instead of mean for comparison here. In most of the cases, when you are going to use the median instead of mean, that means the data is not normal. So we are going to consider example number 6 for our analysis. So this data is related to data on birth weight of infants born to mothers with different levels of parental care. So two independent sample data for univariate analysis. So can we conclude that there is a significant difference between the median weight of infants who provided parental care at first trimester and third trimester? So as a female, you may be understanding this procedure that when a female is going to give birth to their child, uh, the first trimester care and the third trimester care, because the whole procedure basically cover the 9th month procedure for a baby to give birth. So sometimes the first 3 months the care is provided by the parents, and sometimes the last 3 months, like 7th, 8th, and 9th month, the care is provided to the pregnant lady. So does that care basically differentiate the weight, the birth weight of that baby at the time of their birth? If care is provided at the first trimester and the care is provided in the third trimester, does that care differentiate the weight of that baby at the time of their birth? So that is the example number 6. So we have a data set. If I would like to show you, let me open the data set. You are going to use the not normal folder. So here is example number 6 data set. You need to open this data set. Here you would see two type of data here. The first one is weight and the second one is the care. If you open the care values here, you would find here coding scheme. Uh, if the care is provided in first trimester, it is coded with 1. If the care is provided in third trimester, then it is coded with 2. So this is categorical variable. Always remember, that whenever we need to check the normality of the data, always use the continuous variable. So weight here is the continuous variable. If you see the data view, this is the categorical variable, and this is basically the continuous variable. If the variable is not assigned the measure of scale, you should change the measure of the continuous variable. So what we need to do, we go to analyze, we go to non-parametric test, we go to legacy dialog box, we go to one sample PS. Now we need to put the continuous variable, not the categorical variable. You need to put the continuous variable in test variable list and click OK, and you will find a symptotic sig value which is less than 5%. So it is an indication that your data is not normal, because if this value is greater than 5%, then we consider that our data is normal. So in this case, our data is not normal. I was discussing example number 6. So let me show you the complete procedure here. We need to create, there is no statistically significant difference in the median infant weight for the parental care provided between trimester 1 and trimester 2. And there is a significantly statistically significant difference in the median infant weight for a parental care provided between trimester 1 and trimester 2. So these are the statistical hypotheses. So what we have done, this is the usual procedure. What we have done, we have followed the procedure, and we have find out that the data is not normal because asymptotic sig value is less than 5%. So we have concluded that the data is not normal. This is the interpretation where you can find out, since the level of significance asymptotic sig2 tail is equal to 0.001, which is less than 0.05, therefore the normality assumption is not fulfilled. So what is our decision? We are going to use Mann-Whitney U test. So how can we use it? We go to analyze, we go to non-parametric, we go to legacy dialog box, and here we can find out independent sample, two independent sample. This is the test we are going to use. So let me show you from the real procedure. We go to analyze, we go to non-parametric, we go to legacy dialog box, and we need to choose independent sample, two independent sample. Now we need to put the continuous variable here, and we need to put the care variable here. If you remember that one was coded with, let me check from here. This is coded with 1 and 2. So we need to put 1 and 2 in defined groups category. 1 and 2. Continue. Mann-Whitney U is already selected here. Click OK, and you will find the results like this. So these are the results. The mean rank score in first trimester is 25.50, while the mean rank score in the third trimester is 75.50. It means those babies whose parents were provided, whose mother were provided parental care in the first trimester were weight lower, while those babies whose mother were provided parental care in the third trimester were weight higher. So you can see these are the mean rank. These are the average weights of those babies who get birth uh, through these parental care. And if you see the sig value of your test, it is less than 5%. It means there is a significance difference here. So we have concluded that there is a significance difference between the parental care. So the result indicate that there is a significance difference in the median weight of infants between trimester 1 and trimester 3. The finding indicate a significance increase in trimester 3 because their value was higher as compared to trimester 1, which was 25.50, and Z score is this, and P score is this. So we accept the alternative hypothesis. So this is what you need to done. So you need to apply the same procedure on example number 7. You are provided expenditure data of 40 individuals, males and female. Can you conclude that there is a significant difference between the median spending of male and female? So this is your home assignment. So you need to done this procedure. So the time is going to end. Please let me know, Ms. Hina, do you have any question regarding today's discussion?
No,
Uh,
sir.
all right, all right. So let's meet on Monday regarding a new session on the remaining part of two group mean comparison or more than two group mean comparison. So stay blessed. Thank you very much for joining.